In this problem, we're going to investigate a limit by using an intuitive approach. We'd like to find the limit as x approaches 3 of x squared minus x minus 6 all divided by x minus 3. If we notice, this expression is not defined for x equal to 3. If we plugged in 3, in the numerator we'd get 0, and in the denominator we'd get 0. So we'd have an indeterminate form. However, we do notice that x squared minus x minus 6, we can factor as x minus 3 and x plus 2. So we notice that there's a factor x minus 3 in the numerator and x minus 3 in the denominator. And so this expression, x squared minus x minus 6 divided by x minus 3, and write as x minus 3 times x plus 2 divided by x minus 3. We cancel these factors and say that this is equal to x plus 2. However, we do need to understand that these are different expressions. In this first case, we can't use x equal to 3, but over here, we can use x equal to 3 with no problem. So we do need to say that x is not equal to 3 in order for these to truly be equal to each other. When we find a limit, we're really investigating the behavior of the expression as x gets close to 3. We're not really concerned with what happens at 3, just near 3. And so the fact that we're saying x cannot equal 3 is fine. This cancellation is valid for any x that's not equal to 3. And so this expression is just x plus 2. Now, if we wanted to investigate the behavior of this expression, we could do it graphically or with a table of values. We'll go ahead and look at a table of values here. You could use a graphing calculator or some other computer algebra system to compute these values. We're just going to look at the behavior of x plus 2 for different values for x. And so we'd like to pick a few values on either side of 3. So we'll let x equal 2.9, 2.99, and 2.999. So we're going to be getting close to 3 from the left. And we'll use 3.001, 3.01, and 3.1. So we'd be getting close to 3 from the right. And if we put in these values for x into our expression here, we'll get 4.9, 4.99, 4.999, 5.001, 5.01, and 5.1. And so we notice that as we get closer and closer to 3 from either side, it looks like our expression is approaching the value 5. Okay, again, we're not concerned with what happens at 3, just what happens as we get close to 3. So we can say that the limit as x approaches 3, x squared minus x minus 6 over x minus 3 is equal to the limit as x approaches 3 of x plus 2, where we've canceled the factor x minus 3. And we're going to say that that limit equals 5 because the value of the expression is approaching 5 from either side.